My name is Sajid Montezir and here we are with another tutorial on Grasshopper. Let's get started. At first, I type X, Y, Z and bring a construct point component. This allows me to create a point at the origin of the coordinate system. Now I'd like to replicate this point multiple times. To do so, I can make use of the various array options, and here I chose rectangular array and connected the point to the geometric input. Now I need to specify the dimensions of this rectangle and x and y count. So for this, at first I put 11 for x and y count. So this means the point will be repeated 11 times along the x-axis and y-axis 11 times. For the cell, I need to define a rectangle, so I type rectangle and I use 2 points rectangle. Using this, I can define the rectangle based on the coordinate of its two diagonal points. One diagonal point will be located at the origin, which I'll use as point A. For point B, I can make a copy of the first point by holding Alt, as you can see, and dragging it to create a duplicate. After that, I'll modify the component of the new point. For example, I assign a value of 10 to both the x and y coordinates, and I adjust this value to both x and y, as you can see. This creates a rectangle with these dimensions. Then I'll use this rectangle as the cell input, which gives me control over the dimensions of the cell area, and as you can see, I can control this dimension. Next, I'd like to introduce a movable point within this range. To do this, I'll once again type x and y and z, as you can see, and bring another construct point to make the x and y coordinate parameter and easily adjustable. I use an MD slider. So I type MD and bring in the MD slider component. The range I want to define here corresponding to the start and end of the x and y axis. And since I've divided the grid into sections of 10 units each and there are 11 points, the total range for both axes will be 0 to 100. I set this range in the MD slider. Now, in order to separate the x and y values generated by the slider, I use a deconstruct component. I connect the slider to the deconstruct component and assign the first output to x and the second one to y coordinates. As I move the slider, you can see how the coordinates of the point dynamically update within the defined range. Anyway, I'd like to add a z height to this point. For example, I can set a value of 12 and adjust it as needed. And if I change the z value, for instance, to 57.5, you'll notice the point's height update accordingly. Now, my next goal is to calculate the distance between each point in the grid below and the point above. To achieve this, I'll use the distance component. As you can see, this component will calculate the distance between these sets of points. Once I've calculated the distance, I'd like to remap them for further processing. So I type remap. Here I have remap and connect the distance to the value input. To define the source range, I'll use the bounds component. The bounds component helps me determine the minimum and maximum values in the distance list, which I connect to the source input of the remap number component. For the target range, I'll define a range, for example, 10 to 35, and input it using a panel. After entering the range, I connect it to the target input, and also I use space as this stage. The remap values are ready to be used. Next, I want to use these remap values to move the grid points upward. For this, I'll use move component. I'll input all the points into geometry input of the move component. For the motion input, I'll use a unit z component and connect the remap values as the factor. This will move the point upward according to calculated distance. Now with the move points, I can create a surface by using the surface from points components. I'll input the points into geometry input, the u count, which defines the division along the u direction. Should match the value I used for x count and y count earlier. This ensures the surface is created correctly. Right, if you're tired, same as me. So to enhance the visualization, I'll use a custom preview component. I'll input the surface as the geometry and use a color swatch to assign material color. By clicking on the color swatch, I can select a color that looks good. For example, this color. To organize the view, I'll select all the earlier components and press Ctrl plus Q and hide their previews so that only the surface remains visible. At this point, I'd like to add a sphere at the point I created above. First, I'll select this point and press Ctrl plus Q to verify it's the correct point. Once confirmed, I'll use the sphere component. I'll set the point as the base input for the sphere. The file radius is too large, so let's say, adjust it to 12 for now. As you can see, though I can tweak this value later. As you can see, I can change this value and also the value of the height like this. To improve the visualization of the sphere, I can use another custom preview component. I'll input the sphere geometry and assign material using, again, color swatch. So I can pick a color to make the sphere more visually distinct. Finally, I'll switch to render mode to see the result more clearly. At this point, you'll notice that moving the MDO slider dynamically changed the surface, as you can see, and you can observe how the shape evolves similarly. You can adjust various parameters of the algorithm, for example, increasing 10 to 45, let's say, results in greater vertical deformation. It gives me more height, and as it's clear, if I change it, you can see the result. Like this. And here, if I, for example, change the sphere height manually, you can see the result clearly. All right, that is the end of our tutorial. Thank you for watching this episode.